In the following video, I will answer question 8 of the January 2011 Call for OCR paper on implicit differentiation. Okay, let's start straight away. P and Q lie on a curve defined implicitly. The tangents at P and Q are parallel and they have gradients 3/8. That means that dy by dx, the gradient function of this curve, is 3/8 at P and Q. So let's differentiate this curve, the entire curve, with respect to x. So for part 1, differentiate everything with respect to x. Firstly, differentiate the 2x squared with respect to x. You should get 4x. Then differentiate the 5xy with respect to x. Think of it like a product rule where 5x is u and v is y, and the product rule says that if you differentiate uv, it's u v dash plus v u dash. Okay, use that rule and you would get yourself 5x times the differential of this, which would be dy by dx. So 5x dy by dx, okay, plus v, which is y, times the differential of u, which would be 5. So writing that neater, it would be 5x dy by dx plus 5y. Lastly, differentiate with respect to x y squared. Well, I can't do that directly, so I instead differentiate y squared with respect to y and fix by post multiplying by dy by dx. The differential of this with respect to y is 2y, so I'm going to get 2y dy by dx. Differential of 9 is 0 and differential of 0 is 0. So plugging everything in, the whole differentiated thing would be 4x. Now remember, I'm subtracting this, so I'm subtracting 5x dy by dx. I'm also subtracting 5y. I'm adding this, so I'm adding 2y dy by dx. The 9's gone and I get 0. Now, we are told that the gradient is 3/8 at P and Q. That means dy by dx at those points is 3/8. So I can substitute in 3/8 for dy by dx, i.e. here and here, instead of actually making dy by dx the subject, etc. So let's do that straight away. I'll change pen. 4x minus 5x. Now 5x times 3/8, let's just forget about the x for now. 5 times 3/8 is 15 over 8, and you've still got your x. So it's going to be minus 15 over 8x minus 5y. 2y times 3/8, well, 2 times 3/8 is 6/8, so that's going to be plus 6/8y is equal to 0. Okay, let's have a go at let's times everything by 8 just to tidy it up. That would be 32x minus 15x minus 40y plus 6y is 0. 32 minus 15 is going to be 17x's. Minus 40 plus 6 is minus 30. 4y is equal to 0. Adding 34y to both sides and dividing by the 17 will give me x is equal to 2y as required. And you've done part 1. Okay, it says hence find the coordinates of P and Q. Now remember, at P and Q lie on this line. So they certainly satisfy the equation 2x squared minus 5xy plus y squared plus 9 is 0. But they also must satisfy this equation from part 1. So they also satisfy x is 2y. We have two equations with two unknowns, so we can solve them simultaneously. Do a substitution. Wherever you see x in the top equation, write 2y. So that's 2y squared minus 5, instead of x, write 2y and keep your y there, plus y squared plus 9 is 0. Okay, times it all out. 2y all squared is 4y squared. Double it, you get 8y squared. 2y times y is 2y squared, times by the 5, you get 10y squared, and it's a subtract. So subtract 10y squared plus another y squared plus 9 is 0. Combine it all together, 8y squared minus 10y squared is minus 2y squared. Add another y squared, you get a minus y squared. So you get minus y squared plus 9 is 0. Rearranging, y squared equals 9, so y is 3 or y is negative 3. And subbing back in for x into this equation, that must mean x is equal to 6 or x is equal to negative 6. So the coordinates of P and Q are 3, 6 and minus 3, minus 6. Okay, thank you for listening to the video. I hope you found it useful in your revision for implicit differentiation in Core 4.